Hello, everyone, and welcome to the Switch Statement Podcast. It's a podcast for investigations into miscellaneous tech topics.
This is the fifth and final episode on Martin Fowler's Refactoring.
Hello, John. How are you doing?
Hey, Matt. I am doing great. How are you?
I'm doing all right. Just ready for the weekend. We always record on Friday, so I feel like this is a good way to get into the weekend.
Yeah, it's nice. It's what tells me that the weekend is nigh. So we read the rest of the book. I didn't actually read the rest of the book, just like a little admission here. I looked at the table of contents, and I found a bunch of refactorings that I thought were interesting. A lot of them weren't, so I read through a bunch of them, and I picked out ones that I thought were really cool. And that's kind of what I was going to talk about today.
Yeah, I think you implemented an efficient algorithm for finding the interesting refactorings. So
hopefully we'll find out.
But let's just launch into it. I don't know. Did you have a favorite that you wanted to talk about?
Well, I have two sections of things I want to discuss. The first is things from the book. The second is actually things that I invented myself, which are probably like similar to things from the book, or just logical extensions of things from the book.
Martin Odersky is so,
yeah, man.
No, Martin Fowler is so thorough. I was trying to come up with novel refactorings that were not actually just compositions of existing refactorings, and I had a really tough time. I felt like I came up with one that it wasn't in his book and is a true, in the spirit of a refactoring, that I'm pretty proud of.
Oh, wow. But okay, awesome. I'm really looking forward to getting to that. But maybe let's cover the stuff from the book first, just to be as respectful as possible to Martin Luther, and we can move on to stuff we invented after.
I mean, this is basically the 95 theses of refactoring. I mean, I think there's probably at least 95 refactorings in this book.
It's got to be. There's a ton. All right, one that I really liked, and I'm trying to find my favorite one from the book. This maybe isn't my favorite one. I just really like this one. Introduce assertion.
Oh, okay.
This is one that I just feel is kind of a cheat code in programming, that when I've read a ton of like production code bases in my, lengthy career, and a lot of them do not have assertions at all. They're just, I think people have a hesitance to like put them in production code, but put them in your code. There's like no downside to having assertions, and there's really only upside. It follows the principle of failing loudly and failing fast. And anyway, when you compile for production, it generally removes assertions anyway, so there's no cost to them. So I'm a big fan of that refactor.
Interesting. Okay, so an assertion is something that is executed in development mode, but doesn't cause a failure in production.
Yeah, exactly. So I didn't even explain what an assertion is. So basically, a lot of times when you're entering a function, you have arguments. An assertion, or one use case for an assertion, is to check those arguments. Like say you're verifying someone's age. You might want to check that the age parameter is greater than, 0 or something, some age that doesn't make sense. So that's one common use case for assertions. There's tons of others, but it basically just allows you to check anything in the code so that you can gain confidence that the next lines of code are going to execute properly, because they're kind of operating based on these assumptions that your assertions can verify.
So let's say you write a function, you have a bunch of assertions at the top, and then you write the rest of the function as though all those assertions are true.
Yeah.
And then you get into production. If you've removed those assertions, isn't it possible that the rest of the body of that function won't handle that case well?
Yeah, absolutely. And that's a big issue with removing assertions. A lot of languages don't. Java has a thing called, preconditions.
Right.
It's like just a popular library. Those don't get removed. You know, if you validate a precondition in Java, it's going to throw an exception in production. That's actually what I prefer.
Yes.
But, you know, there's other languages where you can compile them out. There's just different compiler modes. So some people do that. I think that's better than just not having assertions at all. But I'm a big fan of, you know, just write assertions, leave them in the code, fail fast, fail loud. I'm all about it.
Yeah, I think a better way as compared to compiling out assertions is to have some error reporting framework where when you're doing development, it's very noisy. If there's some uncaught exception, it just pops up this big window. It's like, hey, just want to let you know something completely unexpected happened, which may not necessarily get surfaced to the user if it's somewhere in the bowels of the program and there's not a meaningful error to show to the user. Then obviously you want it to report to some error reporting system in the back end.
Right. Yeah.
Okay, so one that I saw that I liked is introduce parameter object. And so this refactoring is all about, so you have a method or a function. You're starting to take an increasing number of arguments to that function. And then like calling that function gets very unwieldy. And typically, you know, in most languages, parameters are positional. So let's say you have this shaggy list of optional parameters and you want to pass in the last optional parameter. You have to be like undefined, 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 true, undefined, you know, all these like weird default values explicitly specify these default values. And so I just really like the practice of, okay, wrap all of those up into one object, especially in a language like TypeScript. It's so easy to just define this type right near the function. And it's just going to clean up all of the callers. The other thing that's awesome is like, let's say you have a bunch of Boolean parameters or you have things that are allowed to be undefined. A, if they're undefined, they're just not even going to be in that call. So they're not going to be cluttering it up. And B, if they're Booleans, you're going to have the name of the Boolean right next to it when you have this structured object that you're passing in. So it's like...
Yeah, I love that.
I really like the way Dart does it. Isn't... Like, Dart just has that by default where you can just call it that way.
I was going to mention Dart's kind of calling syntax because I absolutely love it. You can have, you know, positional parameters. You can have named parameters. The way that you have both is really cool. You can also have optional positional parameters. They just have like a very nice syntax for specifying all those things. And yeah, like you're saying, I think named parameters is like, a lot of times it feels like the default in Dart, or it feels like what you should do. And I really like that pattern. I think it's great.
That's what I like. I feel like that is what I would just always do by default, unless I had a really good reason to use a positional parameter.
Totally. Yeah. Name parameters are great. I'm trying to think of the downside to name parameters. I guess it's just more typing.
A little bit of verbosity, I guess, when you're... So like if you have a function with a super clear single parameter, sure, like leave it off. But otherwise, like if you have two, no reason not to name them, I would say.
Yeah, I agree. I love this refactor. I will say there's an obvious downside to this refactor, or maybe not a downside, but like an extreme side of this, where you introduce, I think people used to refer to them as like context objects, where you just introduce this like kind of vague object called like context or something, and you pass it into your function. And that's a case where you can sort of take this refactor to the extreme and lose a lot of meaning that individual parameters might have. But what you're referring to using name parameters doesn't have that problem. This is more in a language that may not have support for name parameters, like Java, where I've seen this before, where people will take a list of like 7 parameters and instead they'll just create this like, you know, call context class. And that's disgusting.
Well, this is the thing. In Java, it's so much heavier weight. It's like, okay, I got to go into this other file and create, or I guess you can have an inner class. I haven't worked in Java in a while, but it just feels like the options for doing this in Java just incur this higher penalty because of the way, just the overhead of declaring a like a data class in Java.
Java is basically missing basic features, so this sort of thing is difficult.
Well, Kotlin, my understanding, Kotlin is coming in to save the day.
Kotlin's great. They copied off Scala. That was a very good thing to copy off of, so I'm a big fan of Kotlin. Another set of refactorings that I really like are inlining. Any form of inlining, I am a fan of. I hate variables. I want to eradicate all variables. I want literally everything to be calculated based on the atoms of the universe. I want to be able to go as low down to the ground truth as possible and literally derive everything at the moment I need it. So I'm just a big fan of inlining anything. I think as I program more and more, I dislike local variables more and more. Like I feel like I move more towards this more functional, maybe it's not functional style, but just calculating everything at the time that I need it, as opposed to like introducing all these locals in order to make my lines shorter or whatever the motivation would be.
Yeah.
So big fan of inlining.
I guess the value of assigning this to a named parameter is you get to give a handle, like a meaningful handle to this function call, or like the result of this function. But I guess what Martin Brodeur would say is that instead of assigning that to a variable, you should just extract the body of that to a function and then call that function, as opposed to assigning it to a variable. Do you feel like that's true?
Well, right. And yeah, that's a case where I've seen a ton, where you're about to call some function and you have arguments to that function. So you assign all these local variables before you call the function so that you have these like nice variables that you can pass into the function. But if your functions that are creating those local variables are named well enough,
it shouldn't be necessary.
Exactly. It should not be necessary. So, and obviously there's cases where you want to create a local variable, and that's fine. But I just think generally I much prefer inlining when it's possible. I think it reduces the amount of lines of code I need to read. A lot of times I can interpret. I think reading code is a lot like reading music. I don't know if we've ever talked about this actually, but it's the type of thing where in music, sometimes you'll see like a series of notes, but if you're reading the music, you'll read them as like one logical unit, and you'll just play it on whatever instrument you're playing, or you'll see a chord that's composed of several notes, but you'll just read it as a chord. It's not like you're not like seeing all of the notes.
Each one of the component parts. Yeah.
I guess I should have practiced describing this before I mentioned it. But anyway, I think reading code is a lot like reading music, where there's all these constituent parts, but you're reading them as wholes. And I think those local variables just like slow that process down.
Interesting.
So that's mine. I like inlining. Big fan of that one.
One that I wanted to point out, there's one that's called separate query from modifier, which I feel like that name is very hard for me to parse.
Yeah.
It's like, what does that mean?
I read that one, and I feel like conceptually it was pretty simple, but the name sounds super esoteric.
It just goes to show you how hard these concepts are to... Like our language just doesn't, and this is part of the point of the book, right? It's to come up with this ontology of these concepts that don't have good handles. But I feel like this is one of the ones that illustrates it most clearly. Just to explain for listeners what separate query from modifier is, because if you're anything like me, you had zero idea what that meant.
I don't even remember what it means, and I read that section.
So the whole point is, you shouldn't be both returning state and modifying state at the same time. Like you shouldn't have something that's like getting and modifying state, or like querying and modifying state at the same time. Right? Yes. So it's like you have a function which is called like get students and assign assignment or something like that. And the idea is like you're using that, and in the method you assign assignment to students, and then also clients of that are expecting to use the list of students to do something else. Which maybe that is a contrived example, but I do think I've seen this before where you try to come up with this godly function, which does a billion things. But it's interesting because you could imagine a service class, which has your business logic, doing a series of these things. And I was trying to think about or distill why that other example is a smell. And I think the crux of it is the return object. If you're doing a bunch of stuff, like if you just have assign assignments and you do have to query the students to handle that, but then you're just returning void or like a status or something like that.
Yeah.
That's fine. But it's when it's trying to do both of these things simultaneously, that is when I think it becomes a smell and something that should be refactored.
Yeah, that's a really good one. That one I am strongly adherent to, or I try to. Actually, there was a similar one that I really liked called split phase. This is another one.
I love split phase. Yeah.
Yeah. When you hear the word split phase, it's like, what the hell does that mean? But let me try to explain this. And I'm glad you also read it because I feel like I'm not going to be able to explain this. But basically, you have a block of code that's performing some ultimate task. And each part of the block of code is doing, let's just say, two kind of logically separate things in order to perform that ultimate goal. Like he used the example of compiling and running a language, which I really liked. Where when you're compiling and running a language, you have to basically parse strings, because you're reading these files as strings. So you're parsing these strings, but you're also building up this, abstract syntax tree representation of the language, and you're maybe even evaluating that tree as well. So there's kind of three logical things that are happening: parsing, creating an AST, evaluating the AST, but they're all happening as you're reading these files. Well, what split phase means is you separate all those phases into logical steps in the program. So you do all your parsing first. You'd kind of build it into this list of tokens. Then you'd build your AST. Then you can evaluate your AST. And I'm a huge fan of this style of programming. I think doing a programming language is a great example, but there's examples. This happens all the time. So split phase, really like that one.
So it's basically like trying to be a little bit more deliberate about breaking it down into steps, like where you could conceive of a function that kind of has a couple of things going on simultaneously. And it's like, no, we're going to define these well-defined interface points where it's like, okay, here's this intermediate representation, and then the next phase is going to pick it up from there instead of trying to do them all simultaneously.
Exactly. Yeah.
Okay. My next one was pretty simple, but I think it's my favorite of all of them.
Ooh,
it just feels the best.
Nice.
Simplest to read of all of the refactorings. I think I might get this tattooed on my body somewhere.
Okay.
Remove dead code. Remove dead code.
God. Yes. That
Everybody
is the
just
best.
just I don't know. Put a big poster of that on your wall somewhere.
Yes.
Remove dead code.
By far the best form of refactoring. Also the most satisfying as an engineer. Just the best thing ever, really.
It just feels so cathartic. Not cathartic may be the wrong word, but it's like it's just a real satisfying feeling.
Yeah, no, it's the best. My paradise is basically just removing code, just deleting code and committing it to the repository.
Did you have any more that you wanted to?
No, I'm pretty much spent. I just have my own that I invented.
All right, let's hear it. Let's hear it.
Okay, well, I have 4. I don't know if we'll have time to cover all of them, and that's fine. Let me read them off to you, and I want to see which ones you're most interested in. So,
okay.
Collapsing the ping pong table. That's my first one.
Oh my gosh.
Don't tell me what to do is the second one. Return to innocence is the third one. And I actually, this just goes to show how much I love removing unused code. But I actually wrote delete unused code as well. Even though Martin Shkreli already included that in his book, I just wanted to repeat that one for some reason.
Yeah, I don't know. I mean, I think that of all of the ones you could have repeated, like that is the one that you should have.
Yeah.
Okay. You got to give me that ping pong table. What is collapse that ping pong table?
So collapsing the ping pong table. This is a pattern, and I don't think this isn't some super common pattern, but I've definitely seen this many times before, where you have some set of service classes. And I'll use the example of like processing transactions, where you might have, in each of your transaction processors, you'll want to create these separate abstractions that are like implementation specific. So one, you might want like a transaction getter and then like a transaction, I'll call it a populator, which just adds more fields to the transaction. And then like a transaction evaluator or something.
Like a transaction enricher, you would say.
Yeah, transaction enricher. Yeah, exactly. And what I have seen before is people will write these individual transaction processor implementations, but they'll also write individual implementations for all of those things I just mentioned. So as a result, when you're reading this code, you're jumping into an individual transaction processor, and then you're jumping into this individual transaction enricher, and then you're jumping back to the processor. Then you're jumping back to this, transaction evaluator thing. And you kind of feel like you're playing ping pong a little bit because you're just jumping from class to class. And obviously sometimes this can be a really good design because you're just separating out your main concerns. But I think sometimes when all of these steps take place, you're not reusing these steps in other parts of your code base. These steps are only involved in this one type of transaction processing. I prefer that stuff to just be like a function in the transaction processor implementation as opposed to some other class. I just feel like some of the benefits of making it into another class are decreased just because it's not used elsewhere. So instead of playing this game of ping pong, I like to collapse that down, put it in the same class. It can be a separate function or something, but just reduce that ping pong action.
I love that. And I think this goes back to what we were saying about speculative generality. I'm sure that at the time, someone was like, oh, we may want to have another kind of transaction processor or transaction enricher, and it's going to be important that we have this flexible system where someone can install a customized transaction enricher. But it's like, wait until you need that. Just don't worry about it.
Yeah, a lot of these go back to Yagni. It's like, just do it the most reasonable way first, and then expand it out when you need it.
Right. All right. So the first one, it's not interesting in its name. I like it because I think it could be in his book, and I think it wouldn't be out of place. It's just called extract constant. As far as I could tell, he didn't have, he had extract variable, and this one's very clear, right? The point is you see this number, this string, what have you, 2-3 times, not a lot of times in the code base. I think it makes sense to very eagerly pull that out into a named constant.
Sometimes even once, like I would argue.
Well, right.
Yeah.
Then you can add a comment about how you picked that number, and it doesn't need to pollute the code in line. And it's like, okay, if someone needs to tune this later, they'll know where to go and they won't have to dig deep into the code to get it.
Yeah.
The other case where this is super important is if there's like two constants that are the same numeric value. Like, let's say you have two things where it's like 500 and 500, and one is the number of milliseconds, you're like the timeout in milliseconds of this call, and the other one is the size of your buffer or the size of some maybe the upper bound of some least recently used cache or something like that. It's like, but it just says 500 at 2 places in the code. Make both of those constants and say, LRU size limit and blah, blah, blah timeout.
Yes. This is, I think that's one of my top reasons for why I love this refactor. It's, you can put a name on something. These magic constants in your code, when I see them, they scare me. I'm like, what the hell is this number, this like random integer? But when you have that name and it's easy to read, it's easy to find, it's at the top of the file, like I just find that to be much more readable and better.
Yeah.
That's a good one. Yeah, I'm surprised that that wasn't in the book, because that one's...
It may have been. I searched constant and I didn't see any explicit refactors that called that out. So.
Yeah, I definitely did not see that. That's a really good one.
All right, what were the other?
So don't tell me what to do is basically, and I think I've only seen this in Java. It might happen in other languages, but in Java there is this insane pattern to create an interface for literally every class you have. And this refactoring is basically just delete the interface. Just use a class sometimes. Like I've never understood this. I understand the need for an interface. You're trying to create this API, and it's obviously super important for like big boundaries in your code. Like if you have like a database layer, like obviously you're going to want interfaces for your main like fetching classes. You're not going to want to just depend directly on some kind of like MySQL fetcher, so that when you change your database to Oracle, you're like totally hosed. But if it's just some class that's inside of a subsystem, not even shared with other systems, like just depend directly on a class. It's not a big deal. Like interfaces serve a purpose. And I think when you're creating an interface for literally every class in your system, you're missing the point.
Right. You're just adding this unnecessary overhead.
Right. Yeah. So, and
what do you see as the main downside to that? Is it just clutter or
extra code? I actually think extra code is a huge part of what makes code bases like harder to navigate, harder to understand. In my career, I've jumped to new code bases a lot. And so I've been forced to like learn new code bases. And yeah, just having to read more code is like annoying. And especially when it's completely unnecessary. It's just, I don't know. The other thing is when you see an interface, at least me, I think to myself, oh, this is like a concept that has multiple behavior or multiple implementations.
Right.
And that's like usually not the case in Java, which is just annoying. Yeah. So anyway, I think it adds a lot of cruft and, difficulty to a code base.
All right. This may be controversial, but I just came up with an idea or new kind of, I don't know, truism. An interface with only one implementation is dead code.
It kind of is.
All right, is that true? I want to feel this out. It almost is. Like, yeah. Is that not?
It's literally code that's just not used, because you're passing directly to the underlying implementation in all cases. So yeah, it is dead code. It's unused code. So I love that, because that means it falls under the umbrella of unused code, which is obviously the greatest refactor of all time. So
exactly. Now you know how to reason about it. Delete it. It's unused.
Love it.
It's
awesome. Yeah, and then just really quick, my other one, Return to Innocence. This one's hard to define, but it's basically just use the language, like use the native language that you're working in, even if it's has warts. And again, this is like a Java one. Like I work in a lot of Java code bases. A lot of people try to implement features of other languages in Java. And sometimes it can be cool, but a lot of times it's just like, just stick with Java. Write Java. Don't try to like implement, decorators, for instance. Or I'm trying to think of other features that people have done. I don't know. There's tons of them. But basically, stick with the native language. And in cases where people have kind of gone crazy and like implemented non-native features in your language, I would argue that that's a good thing to remove and kind of bring back to the basic native language. And there are cases where there's some types of aspect-oriented programming that are really beneficial. But in a lot of cases, I think you can just use the base language. Don't get too creative.
Can you talk about aspect-oriented programming?
Yeah, sure. Aspect-oriented programming is basically a way of intercepting method calls or calls into a subsystem and inserting logic either before or after a method call. A lot of times the way it's done in Java is you create some annotation and you annotate all of the methods that you want to intercept with this annotation, and then you have then you implement some interceptor code that runs before and after the method call. So some languages have this out of the box, and it's a great feature. Like I think Python has like a really nice kind of decorator feature.
Yeah.
But in Java, it's not out of the box, and I would actually recommend. I think there are some use cases for this in Java that are really nice. Maybe like database transactions or something. Some of these concerns that are like very cross-cutting. Sometimes AOP, aspect-oriented programming, is good, but I would say in Java, for the most part, I would avoid it personally.
Right. So it's kind of like square peg, round hole. Like you're trying to force this thing to be something that it's really wasn't designed.
I think so. I think it's introducing, I think it's good to be super consistent in a programming code base. And one way to do that is just to stick with the features of the language. Don't try to, go off the beaten path.
Yeah. Okay, I did have one other refactoring, which hopefully shouldn't take too long, and I think this is almost a pattern more than a refactoring, but I called it New Pillar.
Ooh, New Pillar!
And the
Love that name.
idea of New Pillar is it's just okay. You're making a change to the system. It's just the process by which, or like it's kind of formalizing the concept of. You need to put the new thing in, like, so if you kind of conceive of it as your app as like the roof of your house, you want to get rid of the current pillar, but it's like you need to put the new one in and start supporting the roof before you can take the old one out.
Oh,
right. So you need to kind of make sure that so you kind of have maybe a little bit of duplicative support of this structure for a little while in the period where your clients are moving from relying on the old system to relying on the new one. And then at that point, you can make sure, okay, it's the new pillar is supporting the full load of the roof, and we can kind of take away and you can do that in a systematic way where you're measuring what's happening when people are relying on the new system, and you're making sure that they're not regressing, and you're doing it in this progressive way that allows you to catch any regressions that you may be introducing, ways that the new pillar may not be currently supporting the legacy load. And then, and I think it just ensures safety when you move to a new system. And this has a couple of different manifestations. So were you going to say something?
Yeah, I was just going to say I really like this one because a lot of these are like kind of these abstract rules, and this one just feels very pragmatic. Definitely comes up a ton in the actual real world of programming large systems. So big fan of this one.
And I think it has a couple of different manifestations. This is what I had started to say is you're using New Pillar every time depending on how you've set up your deployment. We're using Google Cloud Platform, and whenever we push a new version of our system, we create, we built a new version of our API, and we're pushing that out to production. Mm-hmm. It always creates the new instances, moves the traffic over, and then downs the old instances. And that's kind of a pretty common or pedestrian example of New Pillar. But I do think there are other more interesting examples where it's like, let's say you want to move your deployment to a new location. Yeah. Right. It's like, okay. Or you're creating a new API, right? It's like, okay, you need to make sure that the new API is hosted in a different place where clients can migrate to, and then you can down the old API.
Yeah.
And so I think it does have a lot of different...
It's a hugely useful practice. There's a lot of like other good practices that it enables too, like dark launches where, you know, your current pillar is the thing holding up production traffic, but you're also passing these kind of like test requests to the new pillar just to see how the new pillar will behave. This is kind of the concept of a dark launch, which is just a really good thing to be able to do in a production environment where you're just not completely certain that the new pillar is ready. So yeah, I really like that one.
I feel like there's a lot of non-obvious practices that you should put in place when you're doing this migration from the old pillar to the new pillar. So I think it could be worthwhile to like, and this is something I should think about is, okay, what are the practices when you're doing this? You know, it's about measurement and it's about canarying, it's about dark launches. And I think there's kind of a lot of richness there to explore.
Yeah. A tiny microcosm of this new pillar concept is experimenting. I mean, this is something that happens all the time in the professional world where you're, you know, implementing some, you know, slightly new feature on a page or slightly different experiment or experience on a page. You wrap that in an experiment so that you can slowly launch it to some percentage of users, you know, see how that new pillar behaves, look at your metrics, see if they're actually clicking on it, stuff like that. So yeah, really good practice in the professional world.
All right. I think that is Martin Short's refactoring in the bag. I don't think... Yeah. I mean, obviously, you got to go read it yourself. There's so much here. You know, this is not in any way a replacement for reading the book because there's a lot of really good stuff in there.
Yeah, really good book. Very, you know, quintessential programming book, really. Talks about so many concepts that are just utterly ubiquitous in the programming world today. It almost seems like a book that was written like today with all this knowledge of, you know, these best practices that have developed over time. Like, it's really impressive to me that this book was written, like, I don't know when it was written, but a long time before a lot of these rules were established. Because,
well, I think this is a measure of its success. Yeah. It's like we're constantly being like, oh, like I already know all of this, and it's because this was such an impactful book.
Yeah,
like,
exactly.
I think that's why, actually.
Right. I mean, this book, it's basically like a Bible, you know, like so many engineers have internalized these rules and follow them really strictly, which is a good thing. So an amazing book, I thought.
This is the last chapter in the refactoring series. And next episode is going to be on the art of game design.
Yeah. A book of lenses.
A book of lenses. Yeah. Wow.
Very poetic and weird. I'm really, really excited about that book, though. So that'll be the next episode. Something to look forward to.
Yeah. No, it should be awesome. I'll see you then.
All right. See you, Matt.